you've done this stuff, guys, like kind of secondary 1, and then you see it in secondary 2 more. But secondary 1, you focus on lines. So you should be able to do this. The reason I chose this is because we're going to use this and need this today. Okay, so I gave you some hints here. This is a line. It has this form, y is equal to mx plus b, where m is your slope. Now remember that slope, guys, is rise over run. So it's easy when you're given a picture to just say, okay, what's my rise over my run? And then the y is the y-intercept, where it's intercepting, crossing the y-axis. So that part's the easiest, so I'm going to start out there. Look with your eyeballs and see, where does this cross the y-axis? At what value? -3. So our y-intercept will be -3. Does everybody get that? Ask if you don't. Okay? And then our slope is rise over run. So you're going to have to focus on 2 points, guys. I always choose 2 whole number points, meaning exact points, and you're going to calculate the distance, the rise, over the distance of the run. So I chose this point and this point. Now, we need to know the rise over the run from how to get from this point to this point. So how many units do we have to go up on rise? 1, 2. So our rise is 2, and then our run is, now we were up here to get to that point, how many over did we have to go? 1, so 2 over 1. So our equation will be y is equal to 2 over 1 x minus 3. Now, guys, what's anything divided by 1? Itself. So we have y is equal to 2x minus 3. Okay, questions on how to do rise over run or anything like that? We're going to use this today again. So that's why I chose this. Does that make sense to everybody? Okay, awesome. Okay, we're all good. How many of you got it right? Just curious. That was a hard one. I'll be pretty generous in my point giving today. If you tried it and tried your best, for the most part, you'll get full points. How many of you didn't remember how to do this at all, but now you do at least? Okay, that's good. That's always good. Very good. Always good as well. Okay, let's get started. You guys saw yesterday, like, when we're learning new stuff, holy crap, we have so much to learn. So we go. And that's awesome. So we just got to get started, though. So today we're doing 1-4. I titled my notes 1-4 because I might even give you a hint in the quiz that says, I look at my 1-4 notes, for example. Sometimes I'll give you hints like that. Okay? Okay, so today we're going to be finding relative max and relative minimum. So really, guys, all we're finding today is maximum values of functions and minimum values of functions. So now we know we're not just dealing with quadratics and stuff, we're dealing with all types of functions, higher order functions, and we have to look at them and decide, okay, what's my maximum value, what's my minimum value? Now maximum, guys, it makes sense. It's going to be your highest point on your graph. Minimum is going to be the lowest point on your graph. Makes sense. We can kind of grasp that pretty quick. So just keep that in mind. Now, as you get those quick little things down, there's a couple things. Some graphs are only going to have a minimum. Some graphs are only going to have a maximum. Some graphs are going to have a minimum and a maximum. And some are not going to have a max or min. So we'll look at some examples of such. Okay, we'll look at some examples that I'm talking about. Am I okay to go about? Okay, so just take brief, like max, high point, min, low point. So just little things like that. Okay. All right, so looking at these. Now, these you won't want to necessarily draw. We're going to do some examples later. I just want you looking. This will be more beneficial for you to look and not take notes during this part. I just want to show you like some examples of some functions that have maximums only, have minimums only, don't have a max or min, and then have a max and a min. So looking at this upside down frowny face, it's a parabola just flipped upside down. Looking at this, first of all, I would just quiz you from yesterday. What's the end behavior on that? Down and down. Okay, that was just a side note. Very good. Okay, anyways. So looking at this upside down parabola, does everybody see how it has a maximum value at the very top? Does that make sense? You have to know this to be able to do this correctly in the future. And then looking at this parabola, this smiley face here, does everybody see how it has just a minimum? It doesn't have a maximum, it has a minimum value. And then looking at a line, it's going that way and that way. Can we peg anything as a maximum or minimum on the line? No. So this would be an example of no max or min. Now looking at this one, guys, notice this would be like a cubic function. It bounces up and then back down and then back up. Looking at this right here, this would be considered my relative max because it's not an absolute max. Like you're right, it's getting larger than that, but that's why we call it a relative maximum. And then this right here is a low point, so it would be a relative minimum. So just fun fact for you, interesting enough, This one has an absolute maximum value, right? It's absolutely the highest point. This one is absolutely the lowest point, true? It's an absolute min. This one doesn't have either. These ones are just relative max and min. If we wanted to be technical, you could say, well, that's not the absolute highest point. Look at all those points higher. You're right, but we're talking with this one, relative maximum, relative minimum. Now you have to be able to see what you're looking for. A max or a min, to be able to do this correctly, we're going to use our calculator, so make sure you have your graphing calculator ready to go. Okay? Okay, so before I teach you how to use your graphing calculator, it's kind of cool because you can just use your graphing calculator. It's going to tell you your maximum value. It's going to tell you your minimum value. But before you can do that, you have to be able to tell if it's a maximum or minimum. So I just taught you how to do that. You look at it, it's pretty obvious. And then we have to get our left bound right and our right bound right. Now you're like, what do you even mean by that? I can't show you until I show you how to do it on a calculator. Well, those are really important things to be able to do this correctly. It's not going to, your calculator will still give you an answer. Your calculator is there something on my face? Or people are like laughing. Okay. Just making sure. Is my toilet paper stuck in my hand? Okay. Anyways, well, you could be making fun of my hat because I get made fun of everywhere I go with this hat. It's really cute though, right? I went into Walmart and this like guy in a wheelchair is like, nice hat, Harry. I'm like, Harry? Like, Harry, what? And I was like embarrassed, and then I like didn't dare wear it again. But here I am wearing it. So, anyways. Okay, thanks. You're so kind. Okay, good. All right, if you learn to suck up, I'll get you through a lot of classes, guys. Okay. All right, guys. Okay. Anyways, back to math. Here we go. So you have to get your left bound correct and your right bound correct. Now, I'll teach you what I mean by that by actually doing it. Here's our first example. So this is where you'll want your graphing calculator and pay attention closely. Okay, so what we're asked to find is the relative max and the relative min, if possible. It might have an absolute max, it might have an absolute min. We're not going to know until we actually do it. So here's our function. Here's our function. F of x is equal to x squared plus 2x minus 5. F of x is equal to x squared plus 2x minus 5. So let's go ahead and graph this on our graphing calculator, guys, and then we'll see what we're going to be finding, either a max or a min or what. Okay, so pulling up my graphing calculator here. Follow me through this. Really, it's different when you're doing it rather than me doing just watching. So please get out your graphing calculators. Okay, so hit the y equals key here with me, and then you're going to type in the function. You have to type it in correctly. So we have x squared, right? Here's our x key. So you hit y equals, clear that out if it's anything in there. So we'll hit x squared, so that's variable x. And then we can use the squared key. X squared, is everybody there? Plus 2x, so plus 2x, and then minus 5. Now, if you ever get error, go back and check this, because a lot of times on accident, people, instead of putting minus, they'll unaccidentally put the negative, or where there needs to be a negative, they'll put a minus. So with your calculator, you actually have to do that correctly. Okay, so now hit the graph key. Let's look at it. Are we going to be finding a maximum, minimum, both, or neither? It's a minimum. This is the lowest point on our graph. So you have to decide that before you go about the next thing. Okay, is everybody here so that you can follow me through the next thing? Very important, and it's different. Okay, are we all okay? Okay, so now what you're going to hit, you're going to go to this second key. This second key, you're going to hit second and then trace. It's going to bring you to this screen. Now look, you can find a value, 0, a minimum, a maximum, an intersection. So we're going to be finding a minimum. So we're going to scroll down to number 3 and hit enter. We're finding a minimum. If you would have put maximum, it's still going to give you a point. It's not going to give it correctly though. Okay, so now let's go through. Now notice, the next thing it's asking me is for a left bound. Now that just means I need you to be left of the lowest point so I know what I'm looking at here. So scroll with your arrows to the left. This is our lowest point right here. Now we need to be left of that. Now does everybody see how my little thing is left of it? Does everybody see how my little dot is left of the lowest point? Does everybody see it? Okay, your left might be different than my left. As long as you're left of that point for sure, you're good to go. So you hit enter. Okay, now it's asking for a right bound. You have to be right of the lowest point. So I'm going to scroll right. Now, it doesn't matter how far right you are as long as you're right of it. So I'm just going to make sure I'm right. Does everybody see how I'm right of the lowest point? I hit enter again. Now it says, do you want me to guess? Well, your calculator is going to guess correctly. So you hit enter again. So our minimum value is at -1, -6. Cool. Ooh. Ah. Okay. Awesome. So our minimum value is at -1, -6. So it might ask you, write it in a point. If it was in a point, -1, -6. So now I could graph that too. I could graph that very beautifully. -1, -1, -1, -6. So that'd be right there. That's my lowest point, right? Everybody? And then I could go through and find the x-intercepts, right? By using the quadratic formula, or if it's factorable. Or you could, yeah. So I'm just going to draw in a rough graph for today, though. I'm not going to care if my x-intercepts are correct for right now. So I'm just showing you what we're doing here. Okay, so we found the minimum value. Now, it might say, now think about it, guys. If it said put it in a point, you put it as an xy point. But what if it said, what's the minimum value? You would only put in the actual minimum value. Our minimum value is -6. That is the minimum, right? Everybody, does that make sense? So it might ask you, put it at a point, but it depends on the problem. They might say, give me the minimum value, and -6 would be the acceptable answer. Does that make sense? I'd probably give it to you if you wrote it as a point. But understand how far down is minimum, and so that would be at -6. Does that make sense, everybody? Yes or no? Can't read you. Okay, awesome. Let's do another one. It just takes practice. Let's do another one. So we have -2x² minus 3x minus 5. So -2x², I'll give you a second to write that down so that you can write it, put it into your calculator and stuff. -2x² minus 3x minus 5. -2x² minus 3x minus 5. So we go to our graphing calculator, and we go to y equals again. You're going to hit clear. Now make sure if you type in -2x, you don't type in -2x. It will say error. So negative is the negative keys down here, -2x². And then it's minus 3x. You got to type in the minus sign. So minus 3x minus 5. Is everybody good? Are you practicing it? Because it's way different when you're doing it yourself than when you're just watching, I promise. Okay. Now, hopefully there's someone on your desk that you can at least kind of watch what they're doing. Now I hit graph. Are we finding a minimum or maximum? We're finding a max. Now this is really important, guys, and you're going to be all taking the ACT this year, and you're going to use this stuff, I promise. You're going to do so much better after you've taken secondary 3 on that ACT. Okay, anyways, now notice I can't see very far down. Does everybody notice that? Now I want to see further down on the y-axis. Is that true? I just want to, because this is kind of out of my comfort zone. I'm like, I can't even see what this function really looks like. So I'm going to go to window. If you go to window, then you can change what you're seeing. So now notice it says x minimum. That means how far, the lowest point you can see on x is -10. We don't need to see further left and right. Guys, look up here. You can see my function. We didn't need to see how far left or right. We need to see farther down. So look at y min. That means how far down on the y-axis that you want to see. So I'm going to go like this and say, now you can test things. I'm just going to go with something like -30 and hit graph and see if that's better. Window. Did that not work? Okay. Y min. -30. -30, and then I hit enter. Okay. So now I hit graph again. Okay, so does everybody see how I can see further down? If I wanted to make my window go further down, I could. I'm not going to. That's good enough for me. I see I'm finding a maximum value. Very important. So now to find that maximum, you'll do second trace. Second trace. And we have to say we're finding a maximum. So you make sure you don't say minimum on accident. This is a maximum. I hit enter. Once again, it's going to ask for a left bound. I hit enter. It's going to ask for a left bound. So I've got to scroll left of that point anywhere as long as I'm sure I'm left of it. And then I'm going to scroll right bound anywhere as long as you're right of it and you're surely right. Then I hit enter and it says, you want me to guess? Hit enter again. So our maximum value is at -0.75, comma, -3.87. So -0.75, comma, -3.87. -0.75, -3.875. So if they said to write it as a point, you'd write it like that. They said, well, what is the maximum value? You would say, well, I'm talking up and down. So that would be -3.875, depending on what they ask. Okay, last example, and then I'll talk to you about one last thing, and then I'm going to set you free to work. So stay with me, guys. Last one. Last one, and then I will pretty much set you free to work for a second. Find the relative max and min of this function. So -x cubed plus 2x² plus x minus 3. Once again, -x cubed plus 2x² plus x minus 3. So I pull up my graphing calculator, y equals, type it in. I'm going to clear that out. Negative x cubed. So I type in negative. And then x caret is raising it to a power, so caret 3. Negative x cubed. And then we have plus 2x squared, so plus 2x. And then I could do caret 2 or squared like that. And then I have plus x minus 3. Plus x minus 3. Now make sure you don't type in negative 3. It's minus 3. Then I hit graph. Okay, looking at this, guys, looking at this, do I have a maximum or a minimum or both? A minimum right there and a maximum right there. Very important that you look and see what you're doing. So we can calculate the minimum and the maximum. Now, I don't need to see this far down. If I wanted to be closer in, I could say, I don't need to see this far down. I'm going to change my window with my y's back to something smaller. I only need to see down like negative 10. And then it's up to you. It's kind of at your own liking. Okay, so now looking at this, guys, I'm going to find the minimum and then the maximum. It's two separate things we've got to do. So I'm going to first find the minimum. Very important that I understand I'm finding the minimum first and do this correctly. So I do second trace. I'm going to find the minimum first. So I hit enter. Now it's asking for a left bound. You need to be left of the minimum. So anywhere left, I'm left. I'm sure I'm left. I hit enter. Now right bound, scroll anywhere right of the minimum. As long as you're right of it, hit enter, enter. So our min is at negative 2.15, negative 3.126, whatever. So I might say round to the nearest hundreds. So that's our min. So I'm going to write that down. Because if you don't write it down and you do the max, the min's going to go away now. So our minimum's at negative 0.215, comma, negative 3.11. And then now let's find our max really quick. So you have to do it again. You'll just say second trace. Now you don't have to do anything. You don't have to clear out your function. Just do second trace again. So second trace. And then we're going to find the maximum this time. Hit enter. Now it's asking for a left bound. Now right there's my maximum. So I am left of it. I'm going to hit enter. Right bound. I'm going to scroll right of it. As long as I'm right, I'm good. Enter, enter. Our maximum is at 1.54, comma, negative 0.3688. So our max is at 1.54, comma, negative 0.368. Okay, so question on how to find max and min. Now last thing before I set you free to work. On the ACT, a lot of times, and on my test that's coming up not in too long, what you got to understand is if you're given a story problem, I always, first of all, when I'm given a story problem, I look to see if there's a keyword. If you see the word find the maximum area and you're given the function, all you're doing is using your calculator to find max. So they'll do a story problem and they'll say, what's the maximum area of this function? And this would be a shame to miss this one on an ACT or on my test because you just use your calculator. It's really easy, but you have to know what it's asking for. So look for the keywords such as maximum. And then if it says find the minimum area or minimum volume or minimum value or anything with the word maximum or minimum and it's a story problem and it gives you the function, then just find the maximum or minimum using your graphing calculator. Does that make sense? Okay, awesome. So now do problems 1 through 5 on the worksheet. I'll give you a while to practice those and then I'll bring you back to me in a sec. Do you have any questions on the calculators, guys? Those come with practice on the calculators, but some of you weren't getting them right and you got to be careful. Maybe you're choosing that you're finding a minimum when you're actually finding a maximum or vice versa. That could be the problem back there. Or that your left bound and right bound weren't correct. So just be careful when you're typing those in. Okay? All right, so now we're going to talk about something a little bit different. We're going to talk about function operations. So you're going to want to watch this and go through this with me. So function operations, and I don't mean operations, but I do at the same time. So I did this for a reason, just to be dumb, but at the same time, it has a good point to it. So what we're going to be doing, guys, is with function operations, what that really just means is we're going to take 2 or more functions, could be 3 functions, could be 5 functions. We're going to take these functions, these different functions, and we're going to perform some sort of operation on them. Now, when I say operation, I mean we're going to add them, we're going to subtract them, we might multiply them, and eventually in this course we'll divide them, and eventually in this course we'll do composition of functions. So today we're going to be doing addition, subtraction, and multiplication. So performing some sort of operation on these two given functions. So addition, this is what it will look like when I want you to do addition. So f of x plus g of x. Hopefully you've seen that before. And then subtraction, f of x minus g of x. So there's a difference between f of x minus g of x versus g of x minus f of x. We have to be careful. Now subtraction is like the operation of all operations. With this one, we have to be so careful, and most people on this one, they throw these, if they're going to put an operation on an ACT, they're going to put subtraction for sure, because 9 out of 10 people are going to miss it because they're not careful, and you're careful if you're good at math, right? So you have to be really careful with subtraction. Now, think about this, guys, in the real world. If you go in to get your leg amputated because you've got a disease, and you go in, and you lay down and the doctor cuts off your right leg instead of your left, and you come out of the operation, are you going to be pretty upset about that? Yeah, right? Like now I have to have both my legs chopped off. And also, once again, things like that, guys, you have to be careful. There's a difference between chopping off a right leg, subtracting off a right leg, versus subtracting off a left leg. Difference, right? Does that make sense? So we have to be really careful. So with subtraction. And then multiplication, guys, is pretty easy. You'll just take f of x, multiply to g of x. But with multiplication, order doesn't matter. With addition, order doesn't matter. With subtraction, we have to be careful because really, we're subtracting all of g of x. So we've got to distribute the negative through. In this one, we'd be subtracting all of f of x. So we've got to distribute the negative through. Okay, so good example there. Okay, let's practice this. So given f of x is equal to x minus 2, and g of x is equal to x squared plus 2x minus 3. We're going to do these couple of things. Now, some of you are saying, I already know how to do this, so I'm not going to pay attention. Do not do that, okay? Or else I'm not going to hand out the worksheets anymore. Because I'm doing these for a reason, not just to be up here talking, okay? So f of x plus g of x. So looking at this, f of x is x minus 2. So we have x minus 2. And then we're going to add that to g of x. So add to x squared plus 2x minus 3. Now with addition, now notice, don't let the parentheses throw you off. I'm just showing I'm adding all of f of x to all of g of x. With addition, those parentheses don't matter because we can add these in any order. So I'm just going to drop them off. X minus 2 plus x squared plus 2x minus 3. And then we're combining like terms. We're just combining like terms. So I would suggest, guys, always starting with the highest power and then working your way down so you don't miss anything. So looking at this, I'm going to combine all x squareds. There's only one x squared. And that's gone. All right, so then combining my x's, that would be the next highest degree. We have x plus 2x. How many x's do we have? Guys, x, okay, thank you back there. So x plus 2x, guys, is 3 x's. Does that make sense? Okay, awesome. Okay, 3 x's, that makes sense. And then I have negative 2 minus 3. Negative 5. We've combined all like terms. Questions on that? Okay, let's do f of x minus g of x. Now this is the operation of all operations. If I'm chopping off a right leg, I need to be careful to make sure to chop off the right leg, not the left leg. So looking at this one, you got to be careful. F of x minus g of x. Order does matter with subtraction. So we're going to take f of x, we're going to take f of x, which is x minus 2. We've got to write that first. So we'll have x minus 2. And then we're subtracting g of x. All of g of x. So we're subtracting x squared plus 2x minus 3. Now, I put in parentheses because parentheses matter in this one. We have to be careful. Now, looking at this, guys, we have 2x minus 2. That's good. But we're subtracting all that stuff. Once again, I'm subtracting all that stuff. So really, guys, if you think about it, that's like having a negative 1 in front and then multiplying a negative 1 through. If you need to do it like that, do it like that. So negative 1 times x squared is negative 1x squared or negative x squared. Very good. And then negative 1 times by positive 2x. Negative 2x, good. And then negative 1 times negative 3. Positive 3. Good. Now we've taken care of the parentheses. We've taken care of the negative. So that's not there anymore. So all we have left is this x minus 2. Does that make sense, everybody? Now some people like to think of it like this, and I'm fine with that. They saw that we had a negative, so they say cross the line, change the sign, but be careful. Make sure to change the sign on everything. So this was positive, it's now negative. This was positive, it's now negative. This was negative, it's now positive. Negative, negative, positive. Does that make sense, everybody? Now combine like terms, starting with your highest degree, being super careful. I have a negative x squared. Does everybody see how I have a negative x squared? Nothing else combined with x squared. Now we have, careful, x minus 2x. Guys, that's 1 x's minus 2 x's, and how many x's do we have? Negative 1x, or negative x. Positive x minus 2 x's is negative 1 x's. And then negative 2 plus 3. Negative 2 plus 3. Negative 2, guys, plus 3.
Negative 1.
Positive 1. Guys, don't be scared. Just, you got it. Okay, here we go. So that would be that. Now, does everybody understand that there's a huge difference between subtracting g of x and subtracting f of x? If we would have switched this and done g of x minus f of x, we would have had to distribute the negative through to this. So just be careful. Subtraction is the operations of all operations. Couple more. So f of x times g of x. Now, once again, f of x is x minus 2. You guys have to put it in parentheses. No ifs, ands, or buts about it. So x minus 2 times all of g of x. G of x is x squared plus 2x minus 3. This will be a good practice for yesterday, because we had to do this yesterday. We're multiplying a binomial, meaning 2 terms, to a trinomial, meaning 3 terms. This one we have to be careful with. X times x squared. X cubed, good. And then x times positive 2x. 2x what? Squared. Okay, guys, properties of x, when it's x times 2x is 2x squared. X times negative 3. Good, negative 3x. And now I'm going to switch colors here, and I'm going to distribute negative 2 through to each thing. Negative 2 times x squared. Negative 2x squared. Negative 2 times positive 2x. Negative or positive, very different. Good, negative 4x. And then negative 2 times negative 3. Positive 6. Then from here, we're going to combine all like terms. I always start with my highest degree and work my way down here. Highest degree is x cubed. Just to pair that, 2x squared minus 2x squared is? Nope. 2x squared minus 2x squared. How many x squareds do we have? 0x squared. Do I need to write that? No. Okay, and then next part. Negative 3x minus 4x. Good, negative 7x. And then plus 6. That's f of x times g of x. Questions on that? Are we going to be careful? As you can see, we can make a lot of little errors. Okay. Okay, guys. This one's the one you're going to probably, it's one like this you're going to see on the quiz. And you're going to see it on your worksheet. So looking at this, this one's a harder one. It takes this one called depth of knowledge much higher than just what we just did. This is much higher because it takes more information to get doing this. So now we're going to perform operations on these functions. These are still functions just like we had before, but before we were given the actual functions. Here we're given the picture. Don't all pictures have actual functions though, like the actual equation? And don't equations have pictures? Yes. So this time though, we're given the pictures and we're going to have to figure out the functions from them. Okay, so looking at this, first of all, how many times is it across the x-axis? Twice. So it's going to have how many solutions? 2. Can't we look with our eyes and see what the solutions are on this one? So let's find the equation of this one. What's the solution? So where does it cross the x-axis over here? So we have x is equal to negative 1, and then over here on the right, x is equal to 2. Now, do we know how to go backwards and find the equation, the polynomial that we started with? We learned this yesterday. Given the zeros, we can work backwards. So remember, we're going to bring these over using the correct operation. I'm just floating them over, guys. We're going to add 1 to both sides. So on the left, I have x plus 1, and now it's equal to 0. Now over here, I'm going to subtract 2 from both sides. X minus 2 is equal to 0. Is that correct, everybody? Are you paying attention? Then from there, guys, remember we were working backwards. We know that before we split these up, they were together. So x plus 1 times x minus 2. I'm working backwards. We learned this yesterday. And then now we have to double distribute. Let's focus on x. X times x is, I'm going to do it up right here. So I don't have to, okay. X squared, x times negative 2, negative 2x, and then positive 1 times x, plus 1x, and then positive 1 times negative 2. Okay, combining all like terms here, we have x squared minus x, right? Negative 2x's plus 1x is negative x's minus 2. So we just found f of x. F of x is equal to x squared minus x minus 2. Questions on that? Okay, let's look at the line. We did this in the bell quiz. Can we find the actual equation for this? Yes. So what's my y? And we know this is a line. Lines have the form y is equal to mx plus b. What's my y-intercept, guys? Y-intercept, positive 3. So that's going to be plus 3 right there. And then my slope, let's use rise over run. So we're going down 1 over 1. So it'll be negative 1 over 1 for the slope, right? So we'll have y is equal to, what's negative 1 divided by 1? Negative 1, right? Negative 1x plus 3. Does everybody see how I did that? Okay, so then we have y is equal to negative x plus 3. Because negative 1x is the same thing as negative x. So we just found g of x. G of x is equal to negative x plus 3. Now it was all that, and I can guarantee you, I saw one just like this on the stage. It was all of that just to be able to perform the operation. So now we found those, now we're going to perform the operations. So now that we found those things, we can go through and find f of x minus g of x. These are what we just found. I just wrote them up here already. Does that make sense? We had to find them first before we can do f of x minus g of x. True? Okay, awesome. F of x minus g of x. X squared minus x minus 2. And we got to put that in parentheses minus g of x. G of x is negative x plus 3. Is subtraction super important? This is the operations of all operations, right? Yeah or no? Okay. So then we got to distribute the negative through. How many of you like to say cross the line, change the sign of that? You don't like that? Okay. Well then let's go like, you like to write a negative 1? Okay, let's do that. Negative 1 times negative x. Positive x, right? And then negative 1 times positive 3. Negative 3. We took care of the negative, right? So now we can just drop these down. X squared minus x minus 2. Then from there we can combine all like terms. Let's start with our highest degree, which is x squared. No other x squared. What's negative x plus x? 0. And then negative 2 minus 3. So we just took care of those. It was 0. And then negative 2 minus 3. Negative 5. Okay, now f of x times g of x. F of x times g of x. So once again, can we rewrite it in as g of x times f of x with multiplication? With multiplication, it doesn't matter, right? So I'm going to rewrite it as negative x plus 3 times x squared minus x minus 2. And I'm going to distribute this through. Carefully, this one's so tricky, guys. Negative x times x squared. Negative x cubed, good. Negative x times negative x. Nope, we're trying to do negative x times negative x. Positive x squared. Negative x times negative 2. Good, positive 2x. And I'm going to distribute the 3 through. 3 times x squared. Good, plus 3x squared. Positive 3x squared. 3 times negative x. Negative 3x, we're getting there. Positive 3 times negative 2. Negative 6. Combining all like terms, starting with my highest degree. Negative x cubed. X squared plus 3x squared is how many x squareds? Plus 4x squared. 2x minus 3x is negative 1x, so minus x, good. And then we have our minus 6. And I crossed them out as I went so that I didn't forget anything. This would be my answer here. Does everybody understand how you'd had to do a couple steps before you could actually do the operation on some of them? Yeah? Okay. All right, guys. So do problem 6 and 7 on the worksheet. Ready, set, go. So guys, now we're going to talk about using, so remember that we were dealing with quadratics for a few days. We were going through and we were solving them and we were getting answers, right? And we were either getting 2 imaginary solutions or 2 real solutions or 1 real solution. So the discriminant is this part of the quadratic formula. So this is our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. The discriminant is just the b squared minus 4 times a times c part of the quadratic formula. And the discriminant will tell you exactly how many solutions you're going to have and what type of solutions. You can look at just the discriminant, if it says what type of solutions and how many, and you can determine exactly how many and if they're going to be imaginary or real, or if there's just going to be one of them, one real solution. So you're going to use the discriminant to do that. I still have that written up here, so by the way. Okay, I still have that written up here. Okay, so if you get a negative number as your discriminant, meaning you calculate b squared minus 4 times a times c and you get a negative number, think about what the discriminant is. That would be a negative number under square root, true? That would be a negative number under the square root. So when you have a negative number under the square root, so let's say our example was negative 49, underneath the square root, that is our discriminant. So you know right away you're going to have two imaginary solutions, but here's why. This will help you not have to memorize it. Think about it, guys. If you have a negative number, negative 49, for example, under a square root, the first thing we do is pull out the negative and it becomes a what? Nope, it becomes a I on the outside. So this is really I square root of 49. Well, okay, so what is the square root of 49 if we wanted to go that far? 7. So really we have 7i. And then we have the plus and minus, so we had something plus and minus 7i over 2a, something. Does that make sense up to here? So how many solutions did we get? How many? Plus and minus means? 2. And are they real or imaginary? Imaginary. So if we get a negative as a discriminant, then we know we have two imaginary solutions. Makes sense. So just think about, okay, what is the discriminant? It's what's under the square root. So if I got a negative, I'm going to have two imaginary solutions. I have seen one like this on the ACT. You'll see this again. Here we go. Okay, so if you get a positive number under the square root, then you're going to have two solutions, right? You're going to solve the plus and minus, but you're going to have two real solutions. It wasn't negative under the square root, so it would be real solutions. We didn't pull out an I. So for example, if your discriminant is 49, that's a positive number, and if we think about what that is, so like for example, the square root of 49 is 7, so we have something plus and minus 7 over something. That's two answers, right? And they're not imaginary, so they're real. So two real solutions if you get a positive under as a discriminant. Now, if you get 0 as a discriminant, you'll have one real solution. So let's think about why this works. If you have 0 as a discriminant, you're going to get one real solution. So let's think about why this works. So the discriminant part is just 0. But if you think about where it goes, that's under the square root. The square root of 0, guys, is 0. So if you think about it, guys, we'll have something plus and minus 0 over something. What's something plus 0? Something, right? Is that any different than something minus 0? No. So does everybody see how really this becomes just one solution? Plus 0, minus 0, same difference. Does that make sense? So this would be one real solution. You get 0 as a discriminant, one real solution. Okay, so while that's fresh on your brain, I practice. Do we need to go through an example, or do you feel like you can practice them? We better do one. So looking at this, f of x is equal to x squared minus 3x minus 7. It says state the number and type of solution. So we can go a long way, do the whole thing, and then look at our solutions and say, I got two real solutions. I got two imaginary solutions. I got one real solution. That's a lot of time. So I would just use the discriminant. B squared minus 4 times A times C. So A is equal to what in this? What's A equal to in this? No, it's the number in front of x squared, so it's 1. B is equal to what? And C is equal to negative 7. Remember, quadratics have the form, guys, ax squared plus bx plus c. It kind of seems like people have forgotten. Okay, so now plugging that into the discriminant, we'll be plugging in negative 3 in parentheses, very important, negative 3 squared minus 4 times A is 1, times C is negative 7. So let's simplify this. This is our discriminant, just this piece. Negative 3 squared is positive 9. And then we have negative 4 times 1 times negative 7. That's going to become a positive, guys. Negative times a negative is a positive. So what is that? Plus 28. So what's 28 plus 9? 37. Is that a positive number or negative number? Positive. So how many solutions are we going to have? 2. And what are they going to be? Real. So this would be two real solutions. Does everybody see how you can use the discriminant to determine how many and the type of solutions you get? Okay. So I practiced problem 8 on the worksheet while that's fresh on your brain. So continue. Okay, guys, with this one, I promised that I would do it because it was really hard. It's on the worksheet. I was going to do it for you as an example in class, but we ran out of time. So what we're going to do with something like this, notice a couple things about this interesting problem here. So we're solving we're solving equations again. Now, we have to be careful with something like this. So we have 8 over x is equal to x minus 2. Now notice we have two x's in the one equation. Now we can't combine like terms in this one. If it was something as simple as like 2x, 2x minus 3 is equal to x, we could combine those by moving the x over from one side of the other, one side of the equation to the other. But guys, with something like this, we can't, because what we have on the left, guys, is technically 1 over x, and on the right we have an x. So those are not like terms, so we can't combine these ones. So we're gonna have to go about this problem way differently. So what I first of all would suggest doing is getting rid of your fraction. This is really the only way to do it though, otherwise it's going to be really messy. So what I'm going to do is I have 8 divided by x. I don't want that fraction. So I'm going to fix it by applying the inverse. So remember, the inverse of division is multiplication. So I'm going to multiply both sides by x. Now, on the left here, what you need to understand and be careful of is x over x is just 1. So those divide out and are not there anymore. That was the point of doing this. So we have 8 is equal to, now here's the other common error. X times all that stuff. I'm going to put it in parentheses so I don't miss anything. If you only multiply it through to part of it, you're incorrect. So x times x is x squared. X times negative 2 is negative 2x. And then from here, we're going to solve for x. Well, now, guys, this is not a linear equation. We can't just easily solve for x by just combining like terms and solving for x piece by piece. We've got to go through. Now, notice this is actually a quadratic. So we've got to go through and use our tools for solving quadratic equations. So we know that we can solve quadratic equations by either factoring if it's factorable or using the quadratic formula. Because remember, the quadratic formula will solve any quadratic equation. So keep that in mind. Before we can do any of that, though, we have to make sure it's set equal to 0. So I'm going to subtract 8 from both sides. So that on the left, I have 0 is equal to x squared minus 2x minus 8. Now, the reason I brought the 8 over is because I always like to keep it positive in front of x squared if possible, because it's easier for me in the long run. So keep that in mind. All right, so now this is the quadratic equation we can solve by factoring if it's factorable, or the quadratic formula. I'll just use the quadratic formula because it always works. Remember, with the quadratic formula, a is equal to 1, b is equal to negative 2, and c is equal to negative 8. Now, if you don't know where I got those, just remember that quadratics have the form ax squared plus bx plus c, and a, b, and c come from the numbers in front of x squared, b comes from the number in front of x, and then c is your constant number. So in this, my a value is 1, and then my b value is negative 2, my c is negative 8. Then the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So then plugging those things in and then simplifying this piece by piece, the opposite of b is the opposite of negative 2. Negative b means opposite of b, so the negative 2 becomes positive 2, so plus or minus, and remember this is x is equal to 2 plus or minus the square root of b squared. B is negative 2. You have to put it in parentheses, especially in a calculator. Negative 2 squared minus 4 times a. A is 1. C is negative 8, so times c. And then that's all over 2 times a. 2 times a. A is 1. So simplifying this down piece by piece, being careful here. Let me grab this and scroll down. Sorry about that. All righty. Here we go. So simplifying this again, we have x is equal to 2 plus and minus the square root of 2. Negative 2 squared, guys, is negative 2 times negative 2, which is positive 4. If you type it in your calculator, you have to use parentheses. So make sure you do that. So 4, and then right here, this is where a lot of common errors come in, guys. In your calculator, you need to type it in as negative 4 times 1 times negative 8. Now keep in mind, guys, a negative times a negative will be a positive. So you better get a positive. So if we do that, we'll do negative 4 times 1 times negative, which is positive 32. So we have plus 32, and then that's all over 2 times 1 is 2. Simplifying this further, continuing to simplify this, I have x is equal to 2 plus and minus The square root of 4 plus 32 is 36, and then all over 2. Now this is where we go off to the side, guys, and we say, what is the square root of 36? If you break it down into the factors, now I always try before I even break it down into the factors, is it a whole root? So the square root of 36 is equal to 6. It's a whole number. Now if you got a decimal, guys, that's when you have to go back and do the factor tree, because we can pull it out prettily. You can pull those things out using your factor tree. Remember, 36 is 6 times 6, then pulling out groups of 2. So we pull out a 6 for those two 6s, and then our house went away. Super important. The square root of 36 is not, a lot of students tend to go like this. The square root of 36 is equal to the square root of 6. You guys, that's not correct. Not correct. The square root of 36, the whole thing became 6. So what we have here is x is equal to 2 plus 6 over 2, and we have another answer. X is equal to 2 minus 6 over 2. Don't leave your answer like that. This is a whole number. These are whole numbers. You can go through and simplify them. So up here, we have x is equal to 2 plus 6 is 8. On top we have an 8 divided by 2, and then that is 8 divided by 2, x is equal to 4. There's one of our solutions. And then up here, just once again, combine the top. Here we go. So we'll have 2 minus 6, which is negative 4 divided by 2. So 2 minus 6 is negative 4. So then negative 4 divided by 2 is negative 2. So we have x is equal to 4, x is equal to negative 2. Those are our two solutions with that. So it took a lot of work, guys. Think about where we started. We started up here. We were asked to find the answers to solve this equation, but it became, when we started solving, it became quadratic. And then we brought the 8 over and got a set equal to 0, and then we went through and had to use a quadratic method to solve. Using the quadratic formula is what we use. If it's factorable, you could solve by factoring. You would factor it down, then set the individual linear factors equal to 0 and solve. Okay, hopefully that helps with those problems at the end. And then last of all, I'm going to remind you how to rationalize the denominator. So once again, if you have this as an answer, the square root of 2 over the square root of 3, it's not in the most simplified form if you have a root of any kind in the denominator of a fraction. So to fix it, well, first of all, this is the square root of 3. That's our problem. So look, if we multiply the bottom by the square root of 3 and the top by the square root of 3, that's okay, because really, the square root of 3 over the square root of 3 is just a fancy 1. Anything divided by itself is just 1, right? So we're just multiplying by a fancy 1 here to help us out. So to put this in the most simplified form. So then with that, you'll focus on the top. So those are both under the square root, so we can multiply them together. And so we're going to have the square root of 2 times 3, which is 6 on top. And on bottom, we have the square root of 3 times the square root of 3, which is really, guys, think about it. 3 times 3 is 3 squared. 3 times 3 is 3 squared. And we know that our root cancels out with our power and leaves us with just a 3. So then this is where you go off to the side and say, does the square root of 6 break down any further? And it does. It becomes 3 and 2, but we can't pull either of those out. They've got to both stay under the house. So we are going to leave it as the square root of 6 on top. Also, guys, you could have thought of this on the bottom as the square root of 9. 3 times 3 is 9. The square root of 9 is equal to 3. So we got the same answer, just in 2 different ways of thinking there. So keep that in mind. I'm going to rationalize another one really quick. I'm going to do the square root of 20 over the square root of 5. This one's going to take more simplification. Once again, the only problem is a root in the denominator of a fraction. If it was just on top, we'd be good to go. So looking at this, I'm going to fix it by multiplying the top and bottom by the square root of 5 over the square root of 5. So then on top, I have the square root of 20 times 5. I'm going to leave it as this. I'm not going to actually multiply them together because we have to actually break that down. So what I have on top is 20 times 5. Keep that in mind. We could multiply that through, but I'm going to leave it like that for right now. And then on bottom, I'm going to go over here, the square root of 5 times 5, which is the square root of 5 squared. So with something like that, our root cancels out with our power, leaving us on bottom of 5. So that brings me to the top part here. I'm going to go off to the side, and I'm going to simplify the square root of 20 times 5. Now, the reason I didn't multiply it together is because I'm going to have to start breaking it apart, again, piece by piece, and I just want to leave it like this so that I can break it apart easier. Because, guys, if we get it down to the prime factors, no matter how we broke this apart, it'll be correct. So 20 breaks down into 4 times 5, and then we won't forget about this 5 because it was there, so we have another 5, and then 4 breaks down into 2 and 2. All right, we're pulling out groups of 2 because it's a square root. So we have 2 5s right there that I have to pull out, and we have 2 2s right there that we have to pull out. So we'll pull out a 5 for those two 5s. We'll pull out a 2. Now notice there's nothing left. Nothing left underneath our root. Nothing left underneath our root. So our root went away. We pulled out the 5. We pulled out a 2 in groups of 2. So we have 5 times 2, which is 10. So on top we have a 10, and on bottom we have a 5. Once again, we simplified that over there, down there, over to the side, and we got 10. 5 times 2. All right, so 10 divided by 5 is equal to 2. So just keep in mind, guys, you're going to have to go off to the side and simplify the root underneath the root if it's possible. All right, so that's everything.